Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering, and we're going to see problems on nodal analysis. I've already shared two videos on problems on nodal analysis, where in first video we have seen problems only with voltage sources, and in second video we have seen problems with current sources and problems with voltage with multiple resistors, whereas here we are going to see problems with both voltage and current sources. You're going to follow the same procedure, right? You're going to combine both voltage. If there is both voltage source and current source, you have to follow the same procedure. You have to derive the equation, and by solving the equation you will find out the corresponding voltages, and then you can able to find out the current across each branches. Right, so with this we will start this particular video. Right, the first thing in this particular circuit, we need to find out the branch currents and voltage across the resistor 5. Right, so now what we have to do is we have to find out the equation. So first thing, I'm going to consider this node as VA, I consider as V1, and this as V2 or VA or VB, anything you want. Right, and now if you take V1, we consider this as I1, and this branch as I2, and this branch as I3. So it will be I1, so I1, this is I2, and this is I3, right? So I1 plus I2 plus I3, that is where we will apply a KCL. Now, how will you write this expression, right, for this I1 branch? I1 branch, all right, this is higher potential and this is also higher potential. So it is V1 minus 10 divided by 1, right? And similarly for I2, it will be V1 divided by 5, correct? And for I3, it will be V1 minus V2 divided by 2. So this is the first expression for V1. Similarly for V2, now you have to be very careful here. You have a current source here, right? So for V2, I consider this as I4, this is I5, and this is I6. So here, once again, you will apply KCL. So it is the sum of current across all branches is equal to 0. So I4, I5, I6. So this branch can be written as V2 minus V1 divided by 2, right? And if you take this particular branch, it is V2 divided by 10, right? And then if you take this particular expression, there is no resistor. You can see the current source is given. The current source is towards this particular node. So it will be minus 2, right? I have already said for current source, if it is approaching towards node, it will be minus. If it is leaving the node, then it will be plus. So you see these two expression, and this is equation 1 and this is equation 2. And by solving this equation 1 and equation 2, you will obtain V1 and V2, V1 value and V2 value, correct? And now after obtaining V1 and V2 value, we can able to find out the current across all the branches, right? We already know the same procedure for finding out this expression, right? What you will do, you will use the same equation, that is V1 minus 10 divided by 1. You will use the same expression for this one, and to find out the current across this particular resistor, it is V1 divided by 5. So you will substitute the corresponding voltage and you will find out the current values, right? The question here is find out the current, determine all branch currents. So you will find out all the branch currents using the same expression, and then you have to find out the voltage across this particular resistor, right? So whatever I explained, I have given very clearly here. So you can see the same thing which I have explained. V1 and V2, we are taking V1, right, and the expression will be V1 minus 10 because this is also higher potential. And if you take this particular node, it is V1 divided by 5, and here it is V1 minus V2 divided by 2. And if you simplify this expression, you will obtain this one. And similarly for V2, right, it will be V2 minus V1 divided by 2, right, and this expression is V2 divided by 10, and this one is minus 2 because this current is approaching this particular node. So you will have equation number 2, and if you solve this equation, you can solve the equation using any particular method. You can use the manual calculation, or you can use calculator, or you can use Cramer's rule. Here we have used Cramer's rule. I have already explained you how to solve problem using Cramer's rule. Please go through the previous video, right? So if this is equation 1 and this is equation 2, delta can be found out using these values, right? This is the delta value, and for finding out V1, what we have to do is this value will be replaced by 10 and 2, and we will find out the V1 value divided by 10, right? And similarly V2, this value will be replaced by 10 and 2, and you will obtain V2 here, right? And the question is, we need to find out the voltage across the 5 ohm resistor, this particular resistor, right? So this resistor, you can see there is no other voltages. So there is only V1 which is flowing here. So the voltage across this ohm resistor is 9.09, right? And if you want to find out the current across this resistor, you will use this expression alone. And if you want to find out the current across this particular resistor, then it is V1 divided by 5. And if you want to find out current across this particular resistor, you will use this particular expression alone. Like that, you can find out the current across all the branches, right? You're going to follow the same procedure, right? But you have to be careful with the plus and minus depending upon the nodes, right? Similarly, now we'll see another problem with nodal analysis with both voltage source and current source. You can see here they have given a current source here and they have given a voltage source here, but they have asked you to calculate only the nodal voltages. So we are going to calculate for A and B. For A, how will you write the expression? You can see this branch, they have already given the current source, right? So you don't have to worry about this particular resistor. So this resistor, this current source is approaching the node A. So it will be minus 10, right? And if you take this particular resistor, it will be VA divided by 20. And if you take this particular branch, you consider this I1, I2 and I3, right? So this branch will be VA minus VB divided by 20, that is equal to 0, right? Similarly, if you consider this expression for node B, you will also write the same expression. It is for node B, it is VB minus VA divided by 20, and if you take this one, it is VB divided by 30, and if you take this particular branch, you can see again it is higher potential and this is lower potential, and this voltage source, it is VB minus 150 divided by 15, and this is the two equations, and if you solve these two equations, you will be able to find out VA and VB. And you can see here the same expressions, minus 10, VA by 20 and VA minus VB divided by 20, right? And you'll find out the equation 1. And similarly for node B, it is VB minus VA divided by 20 and VB by 30, and similarly VB minus 150 divided by 15. You will obtain equation 2. And they have asked you to find out only the node voltages. So by solving this V1 and this equation 1 and equation 2, you can able to find out what is VA and VB, right? So today what we have seen is, we have seen another problem in nodal analysis, and today we have seen nodal problem with both voltage source and current source. I believe this video will be useful for you. Thank you, my dear students.